okay? So we're looking at a sine curve. How many repeating chunks or periods do we have in this picture?
4.
We have 4. So going from negative 4 pi to positive 4 pi, we had 4 chunks in there. How long do you think one chunk is then? 2 pi? Now wait, boys and girls, this isn't complicated. Think about it. We're going from negative 4 pi to positive 4 pi. That's how we have our windows set up. And what's that total distance? What is that? 8 pi's. So in 8 pi's, you saw 4 hills and 4 valleys, right? So does it make sense that 1 hill and 1 valley would be 2 pi? Wait a minute. Why does that make sense? That 1 hill and 1 valley would be 2 pi? Because that's a revolution. And what happens after you have a revolution? You make another revolution that is exactly the same as the first revolution. So your sine curve has a period of 2 pi. What that means is it goes 2 pi and then it repeats itself again. And then it repeats itself again. So when I had you put all this up here, I really had you put too much. You didn't need all that. We could have gotten by setting x min at 0 and x max at 2 pi, and that would have given me my sine picture, right? 1 hill and 1 valley. All right, another characteristic of the wave is what's called its amplitude. How tall are these hills? Can you tell from your picture? I think you can tell. They're 1 unit tall. The hills are 1 unit tall and the valleys are 1 unit deep. So the amplitude is said to be 1. Amplitude is half the distance from the top to the bottom. Since the top is at 1 and the bottom is at negative 1, that's 2, and half of 2 is 1. So it's the height of the hills, basically. How tall are the hills? Now what I'm going to do right now is I'm going to change some of this. So for a regular old sine curve, we have graphed y equals sine x. And because I didn't turn my video on, our x min we had set at negative 4 pi and our x max at 4 pi. And our y min was what, negative 6, and our y max was 6. And it gave us a nice little sine curve, and we have determined that the period of the sine is 2 pi radians, and the amplitude of the sine is 1. All right, so now take that picture out and graph this one for me. What happens when you graph that? Tell me what changes when you graph that on your calculator.
The amplitude.
The amplitude changes. In fact, now those hills and valleys that were going up 1 and down 1 are now going up 4 and down 4. Did it change the period at all? Are you still seeing the same number of hills and valleys? Yeah, so it had nothing to do with the period. It had nothing to do with the horizontal. It impacted only the vertical. So this number multiplies the vertical. Now wait a minute. Does that make sense in terms of what we learned way back in chapter 1? Remember when I graphed these weird things that looked like this, remember? And I said, okay, this is f of x. When I put a number out in front and said, let's do 2f of x, what did that do? Made it twice as tall. What does this 4 do? Make it 4 times as tall. So the amplitude is now 4 and the period is still 2 pi. Without graphing it, tell me about this. What's going to happen to that guy? Patty?
I think it is going to be taller, but inverted as well.
Upside down, exactly. This should flip you over the x-axis. It should turn you upside down. Let's see if it does. Go ahead and graph y equals negative 3 sine. it turn you upside down. Now, I want to make sure you're clear on this. The amplitude is 3, not -3. I know the number out in front is the amplitude indicator, but the negative just tells me to tip it upside down. Amplitude is a distance, and so it will always, these numbers will always be positive. Okay? So the amplitude is 3. Everybody see that? Everybody see it's upside down. So if you start at the origin, instead of having a hill and then a valley, you have a valley and then a hill. No big deal. All right. How do you think we're going to change this? Put a coefficient on x. So let's try that. Let's sketch y equals 2 sine, we'll stick with sine, 2 sine 1/2 x. See what happens when you do that. That 1/2 x does need to be in parentheses. Now, did the amplitude turn out to be 2?
No.
Oh, wait a minute. Height?
Yes.
Look at those waves. Those things should still be 2 units tall.
Mm-hmm.
Okay, so that part we're good on. That's consistent. But now, what about the number of hills and valleys? Remember, you did see 4 hills and 4 valleys? What do you see now? 2 hills and 2 valleys, which means every hill and valley is twice as long as it was before. So our period, instead of being 2 pi, our period is 4 pi. Do you remember that this number right here, and in our notation we used before, it was like this. We were using F's instead of signs. But remember what that guy did? That guy actually stretched it. This number right here divides your period. It divides the horizontal. So what happens when you divide by 1/2? You're multiplying by 2. So the period starts out always as 2 pi. When I put a 1/2 in there, it made it 4 pi. Okay, we'll do one more on the calculator, and then we're going to put those away and do this by hand. Okay, so we've got, let's say we have y equals -5 sine 2x. All right, graph that one on your calculator. And we need to figure out the amplitude and the period of it. Amplitude
Oh my goodness.
Amplitude is 5. Now, it is upside down. It's also very squishy, isn't it? Because now, if you counted, instead of having 4 hills and valleys, you now have 8. So remember, this guy right here divides the period. So what was our period supposed to be? 2 pi. Now it's 2 pi divided by 2, which is pi. Which means you get a whole hill and valley in every pi. So you're getting 4 hills and valleys on this side and 4 hills and valleys on this side. Remember, this number multiplies amplitude, this number divides period every time, no matter what the function. We've done everything in terms of sines. Exactly the same thing is true of every function. Sine, secant, tangent, all of them. Okay? So now put the calculator away, turn it off, put it away. And now I'm going to have you sketch one on your own. Now, here's the good news. Mrs. Ford will always ask you for one period. just one period. So in terms of a sine, that means you're going to draw one hill and one valley. You're always welcome to draw more than that, but that's all you're required to draw. The bad news is there are a few problems in your homework that ask you to draw 3 periods. No big deal. You just draw 3 hills and 3 valleys. Okay? All right, so here's what we're going to sketch by hand. Y equals 3 sine 4x. We're going to draw this by hand. Now, I would suggest that the first thing you do is draw yourself a hill and a valley. That is what a sine looks like. If you've forgotten that, you need to get it memorized. Remember, it was on the gold sheet too. How high are these hills and valleys going? 3. That's easy. So you're just simply going to label 3, -3. That's your amplitude. Now, what is the period? If this were a normal sine curve, this label right here would be what? That label would be 2 pi. Why would that label be 2 pi? Because the standard period of a sine curve is 1 revolution, which is 2 pi. So that's the starting point, 2 pi. But I have stuck a number into this problem, a coefficient on x, and I know that number does what? Divides the period. So this is 2 pi over 4, which is pi over 2. So this one is really scrunched. This label now is pi over 2. From start to finish is pi over 2, half a pi. Can you figure out what this label would be? Because I expect that of you.
1/4 of a pi?
A 1/4 of a pi. Right? Isn't it half of a half?
And then 1/4 of a pi.
And then what's this going to be? That's going to be an 1/8. That's going to be an 1/8 right there. The peak is going to be an 1/8. So there's 1/8. There's 2/8. What do you think this is? Let me say it again. There's 1/8. There's 2/8.
3/8.
This will be 3/8 because that is 4/8. And you're done. Why do we have you label all those little increments in there? Those are the quadrants. Those are the quadrants. Those are the 4 sections. It used to be we went from 0 to 2 pi, so each of these was a regular 90 degrees, but now they're really shrunk up. All right, let's try another one. We'll do one more sine, and then we're going to stretch over to cosine, which is exactly the same. So let's do -1/2 sine 2/3 x. Oh my lord.
Ooh,
Okay.
fractions.
Here we go. We got fractions to deal with. Let's see if we can do it. All right, so first of all, I'm going to draw my sine curve. Now, be careful when I draw it this time.
Is that negative?
It'll be upside down.
You gotta mirror it.
Yep, so I'm going to have upside down. So there it is. That's my negative sine curve. Everybody with me? Anna, did you have a pass?
Yeah, I'm not tired.
Oh, I see it. Thank you. How about amplitude? How high are these hills and valleys going? 1/2. 0.5, 1/2. Yep, no issue there. Notice I'm not really worried about scale. As long as you label stuff, it's okay. If you want to draw them real short, you can. These are short. Now, under normal circumstances, in an ideal world, what would that label be right there? 2 pi. The period of the sine and cosine is 2 pi. But I've changed it. What have I done to my period? It was supposed to be 2 pi. but I have divided it by 2/3. So 2 pi divided by 2/3 is 2 pi times 3/2. What's 2 pi times 3/2? 3 pi. So my period now is 3 pi. Alright, so here we go. It's right here. What would that be right there in the middle? Not 1/2. Not pi over 2. Be 3/2. Kids, come on now. If this is 3, what's half of 3? 3/2. So you can think of it as 1.5, 1.5. I'm going to use fractions all the time, so 3 pi over 2 is how I'll write that, but that's 1.5 pi. All right, what's this one?
3/4.
3/4. What's half of 3/2? Be 3/4. Now stand back, open up your brains, shake out the cobwebs. This is 3/4. This is 6/4. What's this going to be? 9/4. And then with any luck, that should be 12/4. And it is. Everything's evenly spaced. There we go. Alright, now what happens if instead of doing a sine, we do a cosine? Well, the good news is not much is different. So if we wanted to graph 2 cosine 1/3 x, first of all, fundamentally, everything is the same. The only difference is the picture you draw. So instead of drawing this, which would be our sine curve, we're going to draw this, which is our cosine curve. Now remember, Mrs. Ford said you only have to draw one period. So now wait, normally that would be the 2 pi. Does this curve keep going? Could you draw more if you wanted to?
Yes.
Yes. When I draw just that chunk, it looks weird. But that's what the standard period 0 to 2 pi looks like. If I chop off 0 to 2 pi, that's what it looks like. So that's what I draw. My amplitude is 2. My period should be 2 pi. This label right here should be 2 pi. That's what it should be. But I've changed it. What have I done to it? I divided it by 1/3. Dividing by 1/3 is the same as multiplying by 3, so my period is actually 6 pi. So this label that was originally in the original picture you memorized, that was a 2 pi, it is now a 6 pi. Here is the halfway point. What would its label be? 3 pi. Here is the halfway of the halfway, 3/2 pi. So again, you've got 3/2, 6/2, 9/2, and 12/2. All right. Let's try another one. Okay, let's do a cosine equation. Oh, Katie, give me the worst cosine equation you can possibly think of. Y equals.
Y equals 2 pi cosine.
I asked Katie. Let's make it 5/17. So let's make it bad.
Yeah, that's
All right, negative 5/17 cosine 20. Oh my. Okay. Now understand there needs to be. I'll just change this to an 11 because I don't want you to think there has to be correlation between these numbers. There doesn't. Okay. This is as bad as it can possibly get. I'll just tell you right now. This is terrible. But we're gonna be able to manage it. Here's the good news. The good news is you're gonna be able to sketch that right off the bat because you notice it's a negative and it's a cosine. So there we go, right? Would you agree that's your negative cosine? So I just start with that. That will never change. Every time you draw a negative cosine, that's what you're going to draw. Now the fractions are going to impact the labels. Now the vertical labels though really doesn't matter, right? What will our vertical labels be? I don't care, you make those as bad as you want. This is 5/11 and this is negative 5/11, so that's all I have to do with that. Amplitude is 5/11. Everybody okay with that? And remember, if there is a question that says, what is the amplitude? Be sure you say 5/11, not negative 5/11. All right, period. Okay, this is where it gets messy. What is the period supposed to be? 2 pi. We always start with 2 pi. But we've stuck in this horrendous number, so that's going to divide the period. So it's 2 pi divided by 20/17, which is 2 pi times 17/20, which is 17 pi over 10. If I did my arithmetic right, let's make sure I did that right. Is that right?
I think you did.
Think I did? That means that the period is 17 pi over 10. So we're going to end up out there, our last hash mark. So the shape is accomplished between 0 and 17 pi over 10. That's our new period. This is the halfway point, right? So what's it going to be? 17/20. Now, for those of you that are thinking, oh, stop it. We need half of 17/10. Half of 17/10. That's 17/20. Now, guess what I need right here? I need half of 17/20. 17/40. Now, I'm not saying the pi, but I'm including the pi in all those. That's 17 pi over 40. Now, this is 17/40. This is 34/40. So what are we doing here? This was 0. So it looks like we added 17/40.
51.
Added 17/40. What's this one going to be?
51.
51/40. And if we add another 17, we should be at 68/40. Does that reduce to 17/10? Yep. All the little sections are 17/40. So the bottom line is, the trig is easy, that arithmetic is kind of yucky. But we got to deal with that, and it just is what it is. All right, you okay with that? Okay, I'm going to give you one more problem, and then I'm going to give you one more problem, and let's see if we can figure this out. No calculator. I'm gonna up the ante a little bit.
So would you give us one like that?
No. I mean, I will give you one where you have to deal with the fractions, but my goal is not to, just have a bunch of bad fractions. All right, here we go. Now, what has changed? What have I done here? Somebody who said that, I translated it. I put an addition or a subtraction into my problem. All of these multipliers here do what? Stretch and shrink. That's what multipliers do. When you start putting in pluses and minuses, what happens? You're picking it up and putting it down someplace else, right? Either sideways or up and down. So, what's happened here? Look where the subtraction is located. What's happened? It's moved to the right 5/3. Oh, 5/3, 1/3. Move to the right 5/3, 1/3. Okay? So here we go. That means that the curve that used to start here now starts here. Does that make sense to everybody? We have picked it up, and the normal sine curve looks like this. So we've taken that picture and shifted it over 5/3. Everybody okay with that? Now, has that influenced the amplitude at all? No, the amplitude is still 2. Has that changed the period? No. No. Now, will it influence these labels? Absolutely. But it doesn't influence the length of the curve. The period of this guy is supposed to be 2 pi. But I have divided that by 4. So my period is pi over 2. Now this is where we need to put the skids on, because I have programmed you, it's totally my fault. I have programmed you to say, oh, the period's pi over 2, so I'll just label that pi over 2.
Big man.
Not this time. That's fine as long as we're starting at 0, right? But I'm not. So how am I going to find out? My period is pi, this is pi over 2. How am I going to figure out what that end label is down there? Take pi over 3 and add pi over 2 to it. So this is going to be pi over 3 plus pi over 2. Oh, crap. Fractions. Common denominator. That's going to be 5 pi over 6. Everybody okay so far? All right, but now it gets worse, because I have programmed you, and again, I'll take complete responsibility. I have programmed you to say, okay, this must be half of that. No, not anymore. This is the midpoint of these two. Would you agree with that? That guy right there is the midpoint of these two. How do I find midpoint? I don't subtract. How do I find midpoint? I average. I can't say that enough. The midpoint is the average. So how do you average two things? Add them and divide by 2. Or, since they're fractions, we might add them and multiply by a half. So I have 1/3 and 5/6. I'm leaving the pies out for a moment. I'm going to add those. Okay, so what do I get when I add them? 7/6. And then I gotta cut it in half, so this label is 7/12. Okay, so let's recap, make sure everybody understands where so far these three numbers have come from. That one was the horizontal shift, we call it the phase shift. That was the phase shift of the problem. It's the horizontal shift, and it was pi over 3 units. We went right pi over 3. The curve started at pi over 3. Where did that number come from? Added the period. So this number is the starting point plus the period, which we calculated to be that. Now, where did this number come from? It's the midpoint or the average of these two. All right? Now, how are you going to get this one? You're going to average these two. So we have 1/3 and 7/12. So I get a common denominator, 1/3 and 7/12. That's 11/12. Half of that, remember you're averaging, would be 11/24. And then you get to do this one. Same thing. It's the average of these two. So 7/12 and 5/6. Get a common denominator. That's 17/12. Half of that is 17/24. Woo!
Wait, how did you get the middle, like the 11 pi?
You average these two, add them together, and then multiply by a half. Divide by 2, multiply by a half. So you get a common denominator, 11/12. All right, I'll see you. When do I see you again? On Monday. Okay, great. Oh wait, that's on Friday then. Can't go to
Forgetting I'm on camera. You are wrong.